Party bell's in about 2 minutes.
You said 2 minutes?
Well, a minute and a half.
That's not enough time for you to get water.
That's true. You should have planned that as part of your morning routine.
It's kind of tough.
I didn't have
Way
time
over
to
there.
No,
It's actually crazy how far
you
the
just come 2 minutes earlier.
Like by the time I walk into the school building, I only have 1:40. Kids walk up here.
10 minutes?
2 minutes.
You got 10
Set
minutes
up.
to come in the
Go
building.
there and back. It could be like a 4 or 5 minute walk.
Okay, I don't know where you're going to go to college,
The one by the bath.
but university's 10 minutes between classes too, and you have to go across campus.
I can run. I can run to those.
I misspelled my own
outside.
name.
I can't run in the hallways.
Football game was a little scary. Dude, that was crazy.
15 pounds of high school strength.
Good morning.
Good morning.
Because they always end up losing.
I won it. We won. It was
Or putting way too much pressure on yourself at the very end. Did we lose yesterday? No, we got close.
We didn't play yesterday.
Oh, it was Saturday. Oh my god, it's the
I assume you didn't go there.
No.
That's the best option. What were you doing?
Okay, if y'all just came in, you need to see that you need to turn in assignment 15. Also, I did mess up the numbering, but it says on the board how to fix it, so I apologize.
What happened, Mr. Johnson?
I misnumbered your handouts. I made more than 116.
Is it pronounced Jewish?
That is not pronounced Eulers.
It's Euler.
That's not it either.
It's Euler.
There you go.
Euler.
It's not really what it
Just
is,
barely.
but I guess it is.
Make sure your name's on it, and then I need your homework.
It's really alright.
Good morning.
Oh my god.
Don't be
stingy like that.
2024. Will you please join me for a minute of silence?
Where is he?
And then the silence, guys. Please be quiet.
Thank you very much. Will you please stand as you are able for the pledge?
States of America. Nation, under God, indivisible, with liberty and justice for all.
Okay, so one more time, officially asking for assignment 15. If I don't have that from you, I need it in the next couple minutes here, or it will be counted late. Okay, you guys picked up 4 handouts today. We're going to just do 1 page of assignment 16, and we're going to look at all the pages of assignment 17. I know that I messed up the numbering, so 2 of those are supposed to be number 16, and 2 of those are supposed to be number 17. So that's kind of the downside of me trying to number them before I run off copies, is sometimes that's going to happen. The one that says Euler's method on it, that one's supposed to be number 17.
I think it says Euler's method.
Oh, it's Euler's method. So let's go ahead and talk about the 1 page of 16 I'd like to do real quick. This is a AB topic, but it's one that a lot of people were having questions about last week as those questions came up, and those things are going to come up again. And then we'll talk about Euler's method and what it does, and that's in one of our new BC topics. So that will be new to you.
Mr. Johnson, this one's supposed to be 17?
That's correct.
Are 2 of the ones that say Euler's supposed to be 17?
Correct.
Okay.
This is number 16.
Euler's.
Sorry. Hey, it's all good. I did it better.
I just took offense a little bit. It's all
I'm
right.
sorry.
It's okay. It's all right.
Okay, go to the back page. Okay, so these technically, okay, we're going to look at the last page of 16. Just so you guys know, for your own sake, this worksheet's about the fundamental theorem of calculus. There's more than one fundamental theorem of calculus. There's actually two. Which one is considered the fundamental theorem of calculus and which one's considered the second fundamental theorem of calculus? People have disagreements on that. I mean, obviously it doesn't really matter, but one textbook might call this just integrating this guy and dealing with the bounds. The dealing with the bounds they call fundamental theorem of calculus. Some textbooks call this the second fundamental theorem. You've been practicing that already this year. The part that I would like to practice with you, because it's a skill that you need for some of our BC stuff, is this type of question. When you want to take the derivative of an integral. So, just for this one question, I'm going to ask that you do the long method, which is what I'm going to do with you on the board, so you can just follow along with me. But then we'll look at the answer and see what the pattern was, so that we don't have to go through this every single time. Okay, so we know how to do antiderivative of t cubed, or I'm sorry, t squared, and the antiderivative of minus 3t. Let's raise the power by 1, divide by the new power. And then we could evaluate from negative 3 to x. So we're going to plug in x everywhere there is a t. Yeah, I'm on the back page. Plug in an x everywhere there was a t, and then I can plug in negative 3 in everywhere there was a t. Okay, and then this, let's see what we've got here. We've got a 1/3 x cubed minus 3/2 x squared. For this, let's see, this would be negative 27 divided by 3 would be negative 9. Distribute this would be plus 9. This would be 9 times 3 would be 27. Distribute this would be plus 27/2. Plus, okay, I'm just double checking real quick since I did that arithmetic in my head. Yeah, okay. So we get down to this, and of course we could add these two together. 9 plus 27/2 is 22.5, or 45/2. So we get 1/3 x cubed minus 3/2 x squared, and then when you combine these two, you get 45/2.
Should it be plus or minus?
Where?
If you come up one, you have the 9, which comes from the minus 3 squared.
This is negative, but when you distribute this negative, it becomes plus.
Okay.
This would be negative because of this, but then when you distribute this negative, it becomes plus 2. Okay, but what you have to realize here is all I did was I did this integration. So this is still what f of x is. Okay, I integrated it. Now, if we go back up to the directions, it wanted to know what's the derivative of f. So now that I know what capital F is, I can do power rule here, and the derivative of a constant is what? 0. So there's the answer. Now, in theory, I guess you could do this every single time. The antiderivative wasn't that bad. Plugging in x was easy. Plugging in negative 3 was a little trickier with the arithmetic. But then I just turned around and did the derivative anyway. So this arithmetic here, you may have noticed I was being a little bit careless. Why was I being careless with this and what it equaled?
Because it's just going to go to 0.
Yeah. Whatever the constant was going to go to 0 anyway. So if we look at the original question, there's a pattern here where we don't have to do this every time. If you want to take the derivative, it's got to be in this order, the derivative of an integral, and the bottom is any constant. It doesn't matter what the constant is because the constant ends up creating a constant anyway. All that you end up doing is you end up plugging in this upper bound everywhere else there was a variable. So you end up with an x squared minus 3x. And notice, if you recognize it's that question type, you can skip all of this. That should be about a 5-second question. You want to take the derivative of an integral, the bottom's a constant, the upper limit plugs into all the values. Okay, so I'm not going to make you go through this long process again, but I do want to knock out all 6 of these. There is one more catch to these. So I do know that, just like I talked about, if I want to take the derivative of an integral and the bottom is any constant, the upper bound just gets plugged in everywhere there's a variable. So this would be cosine squared x over 1 minus cosine squared x. Everywhere there was a t, I put a cosine x. But the one thing that you also have to take into account, you have to memorize this unless you're willing to do the long process every single time. You have to remember to multiply by the derivative of the upper bound. It's actually a chain rule step, just kind of hard to see why it's chain rule.
Could you explain a little bit as to why we have to do that?
The only way to see how to do that, work it out the long way and you'll see why it creates that. But if you know those two things, the derivative of an integral, again, are meant to be very quick and easy questions. I would like to take the derivative of an integral. The bottom limit is a 0, so the top limit gets plugged in everywhere it can. Okay, and then this still needs to be multiplied by what? 3x squared. The derivative of the upper limit. That's it. Again, you can work it out the long way if you want to. You're going to come out to the same answer. It's just that this happens so frequently that it's nice to know this shortcut. Okay, 24. Derivative of an integral where the bottom limit's a constant, the top limit gets to plug in everywhere it can. And in this case, we would also need to multiply by what?
E to the x.
E to the x, because it's the derivative of the upper bound. All of that makes up the derivative. Okay, you try to write down the answer to question 25 before I do it on the board. It's okay if it's wrong, at least you'll see. Okay, never mind, I didn't look ahead. Why does 25 and 26 not match these same question types?
Constant.
Right. It only works if the lower limit is a constant. So you have no choice but on those two to work them out the long way. Do the antiderivative, plug this in, subtract, plug this in, and then turn around and take the derivative. So there's no shortcut or pattern there. Okay, but again, I think there was a person or two in here that told me they didn't remember this last week, and there was definitely a couple people in 5th period that said they didn't remember this last week. The fact that it's called either the first, whether you want to call it the first or the second fundamental theorem of calculus, is still a fundamental theorem of calculus. It's important that you know that. So these are the only 4 I'm asking you to do on this one today. Obviously, like we've been doing, I will ask you to practice the others as time permits. But is there anything you'd like to clear up about these 4? Okay, I'm going to strongly suggest that if you did not remember this from last year, you might phrase what we did in words, something that if you look back at this, you'll remember how we did this in case you forget it again moving forward. So I will pause for just a second, let you do that if you need to. then we will look at number 17. Again, if you came in late, this one says 16. It's actually supposed to be 17. That was my fault. So please number it. If you don't number it, fix the numbering now, and later on you turn in the wrong assignment, I will still count it late because you should be changing it right now. Okay, so Euler's method. Again, this is another BC only topic, so obviously you didn't have to know this for AB, but it's another topic where we're really just piecing together other calculus things that we already know. So what Euler's method is trying to do is it tries to approximate a solution to a differential equation. So we know how to solve some differential equations, the separating the variables, integrating both sides type of thing. But sometimes approximating is as good as you can do. So this method does a very, very good job of approximating without real complicated calculus. So right here, you need to make sure that you label this guy. This is called the step size. So this is how much it's going to be jumping each time. It's how much we're going to move. Delta in mathematics means like change. So delta x means the change in x. So x is going to change by 1/2. And really what we're going to do on this front page is we're going to deep dive with a picture here so that we get a better visual of what we're doing. But most questions won't really take this long. So what we would like to do to start off, step 1, is let's construct a tangent line at 0, 0. There's 0, 0. And let's write out the equation. So y minus 0 equals the slope x minus 0. So how do we usually go about finding the slope in calculus?
2 points. Derivative.
Derivative means slope. So, well, we already have the derivative. So if I plug that point into the derivative, 1 plus 0 would be 1. So at the point 0, 0, it has a slope of 1. And we are going to use this step size for 0.5. So we're going to go from 0 to 0.5. We're going to say it has basically this equation. Y equals x. From 0 to 0.5. Again, I know I'm moving 0.5 over because that is what the step size is in this question. Okay, now we've got a new point. Our new point is right here. That was our starting point. Our new point is now at 0.5 comma 0.5, or 1/2, 1/2. So what we're going to do is the same thing. We're going to construct a tangent line at that point, but just from 0.5 to 1. So if I set up my tangent line equation, y minus the y value equals the slope times x minus the x value. And again, slope comes from derivative. So using this derivative formula, 1 plus the y value is going to be the slope. So 1 plus 1/2 would be 1 1/2. So now what we're going to do is we're going to let this tangent line equation estimate during these times. So from 0.5 to 1, I want it to have a slope of 3/2. So from 0.5 to 1, I want it to go up 3/2. Over 2. Okay, but I need to cut that in half because I can only go to the right one. So up 1 1/2, right 1. So right there. So this point now has an x value of 1 and the y value was 1.25. So again, if you just glance at this, you wouldn't think anything different was going on. But I basically figured out the slope at this point, used it for one step, found the new slope at this point. I used it for a step. And then I'm just going to keep doing that a couple more times. And then you know what a solution to a slope field looks like. It's just a little bit more accurate because we're not just kind of guesstimating the flow of it. We are, every 0.5x, we are recalibrating what it's supposed to be. Okay, so now we have a point. So this point was at 0.5, 0.5. And now the new point is at 1.25. So we're going to do another tangent line at this new point. I'm just doing the same steps over. The point's just moving. So this tangent line, I could say y minus the y value, bless you, equals the slope times x minus the x value. And this tangent line is going to estimate during these times. So to find the slope, you need to use the derivative. So again, the derivative's at the top. The derivative is 1 plus whatever y is. So that would be 2.25 or 5 over 2. So again, just during these times, I'm going to graph this line. From this starting point, I'm going to use this new slope. So from 1 to 1.5, I want the slope to be 2.5. So it's got to go up. Well, to go right a half, it's actually going up. Yes.
5 times 2.5.
One more time.
1.14, right?
5 halves is 2.5.
Yeah, and it's 2.25.
Okay, I don't know where you're talking about.
I'm just saying 5 halves
tangent.
does not equal 2.25.
Yeah.
Oh, okay. Well, that helps. I hope. This would be 2.25. I'm sorry. I should have plugged this point into the derivative. The derivative is 1 plus the y value. So 2.25, which is not 5 over 2. Okay, but if we use this slope again, so what did we say the slope was? So I don't have to go back.
2.25.
Okay, so that would be if you go over 1, I'm going over a half.
So it's at 1.14.
1.125, something like that. So it's going to go up this much to go right this much. To go right this much, it's going up. Okay, see, 1 is 2 blocks. So 1, 2, and then up another 0.25, which would be about right here. Okay, and that is at 1.5, 2.375. Okay, so let's, again, this is the longer process. I can kind of simplify the process as far as answer getting you. But this is, can you sit down, please? Brandon, sit down, please. Okay, so again, all we're trying to do, here's this differential equation that's been graphed. We're trying to make a good approximate solution to it. So we've already, with slope fields, talked about sketching in lines, but with this one, all we're doing to make it just a touch more accurate, how Euler designed this, is he found a starting point, he found the slope during that point, and then he used that slope for a while. And then at the new point, he found the new slope and used that slope for a while. And then at the new point, he found the new slope and used that slope for a while. And by doing that, by updating the slope every once in a while, it's a little more accurate than you know, just assuming that it's going to be the same thing all the way through. So on the next page, we'll do the same thing, but we'll look at it in a table format. So question 2, the dy dx is 2x, so that's how we're going to get our slopes as the point moves. Y is the same thing as f of x here, and we want it to be a solution to a differential equation. We know when x is 1, y is 3, so go ahead and add that to your table. When x is 1, y is 3. We want to approximate what f of 2 would be using Euler's method with 5 steps of equal size. Now, this is pretty uncommon. 5 steps is a lot. 5 steps is kind of tedious. Usually it'll be like 2 or 3, but for this example we're going to do 5 steps. So if I know the value at 1 and I'm trying to evaluate the value at 2 and I want to do that over 5 different steps, what do you think the next x value would be?
1.2.
Which would make the next one,
1.4.
and the last one should be 2. We're starting at 1, we're trying to get to 2, and they're telling us to do this over 5 single steps. Okay, how could I go about finding the rest of this? Oh wait, no, never mind. Don't do that. Don't do that yet. We don't know that yet. Okay, so our change in x, our step size, was 0.2, and that was coming from 2 minus 1, the distance we're traveling, where we're going to, minus where we started, over how many steps that we want to take. You might want to write that out in case you need to see that. Okay, after that, they have the regular old point slope formula that you're familiar with. The next step is they added this y1 over, but the formula that you probably want to memorize to make this a lot less mental juggling here is that the new, and we could have done this on the last one, it's just that we had the picture to keep up with it. The new y value is always coming from the old y value, which I'll call y1, plus the derivative times the step value. Okay, you'll see how we're going to use this to help us fill out most of our table. Okay, but I know the first point. I know the first point's at 1, 3. What is the derivative at that time? 2. Very good. Here's the derivative formula. It says for this equation, the derivative is always 2 times whatever x is. Okay, so we were at this point, 1, 3. The new point comes from this, and you need to write this, all this on your table. This would be the old y value, which is 3, plus the derivative at that time times the step value. So basically, we're starting at this y value, and we're doing rise over run at this speed, but we're only doing rise over run for 0.2 of an x. So if you do all of that, you get 3.4. So if you're at the point 1, 3, and you go for a slope of 2 for 0.5x, this is where the next point would land. So here is your new point. And then we can do the same thing. Now at this new point, we can update the slope. Slope is 2 times x, and now x is 1.2, so that would be 2.4. And then once you memorize this formula to find the new point, you can take the old point, 3.4, plus the slope at that time, 2.4, times how much you wanted to move, times the change in x. And all of that gives you 3.88. Now you can see that you pretty much need a calculator here. No one's trying to do this arithmetic by hand, so don't get up and get a calculator this instant, but you will need one today. Okay, so now we know where the new point is, so let's carry it down. Now when we're at this point, it's got a new slope. We're updating the slope every 0.5x. So 2 times this x value would be 2.8. And so if I grow at this slope for half an x, it's going to go from this y value. It's going to start here, plus how it changes is the slope at that time for how long you're using it at that time. Notice the 0.2 is consistent. So if you threw all that in your calculator, you get 4.44. So now we're at the point 4.44. At that point, it's got a new slope, 2 times x. And then what would I throw in my calculator to get the point at the next point? Very good. The new point, or I guess it's the old point now. Old point plus how it's changing for how much time. Throw all that in your calculator, you get 5.08. Okay, somebody else tell me what goes in this spot.
5.08.
Okay.
3.6 times 0.2.
Oh, I just wanted this one.
Oh.
Okay, this would be the new y value, where we ended here. Okay, how did you come up with this?
I just plugged it into derivative.
Right, so derivative formula, 1.8 times x, or times 2 gives us 3.6. And then I didn't hear all of what you said, but I think you said 5.08 plus 3.6 times 0.2. Is that correct? Okay, and then that gave you 5.8. Anybody throw that in the calculator? Okay, so there's 5.8. Okay, what would this be?
4.
What would this be?
5.8 plus 4 times 0.2.
Okay, what does that equal?
6.6.
Okay, what does that mean? Yeah, but did we care about that? No, we never cared about this. This part, you need to cross out. Who cares? Right here, this is what we were trying to estimate the whole time. Read the question again. Approximate f of 2. F of 2 is approximately 5.8. Now again, it's an approximation. The only way to know for sure is to solve the differential equation. But again, there are differential equations that are just unsolvable by hand. So this is a nice estimating. We started at a point. This was the slope, so we used that slope for 0.2x. Got us to this point. It had a new slope. We used a new slope for 0.2x. Just kept updating and inching our way over. Now, obviously, if you wanted this to be as accurate as possible, what would you need to adjust here?
Increments, or like the change in x.
Okay, what would you want the change in x to be? Big number or small number?
Really small.
Right, so if you got the change in x to be, like if you had a computer or something, you could tell the computer to make this be like almost 0, and then it would be pretty accurate. So, okay, so I would like you to try this one on your own first, and then we'll discuss it as a group. If you need to borrow a calculator, now would be a good time. But I want you to give it a shot, and I'll go over it with you to help you correct what you need to be looking at differently. And then I'll let you do the rest of the practice. Of course, just kind of looking at this lesson as a whole, too. I mean, you can see you got some pretty nasty decimals sometimes, but these are typically calculator questions unless there wasn't a lot of decimals. There is a formula you need to memorize to find that new y value. I think it's worth memorizing that, so you're not trying to do what we did on the front page and just try to piece it together. That's a little bit too slow. But short of that, I think probably the most important thing is just understanding what you're trying to do. Oh, did anybody do the ACT this weekend?
Yep.
How was it?
It's all right, I think. Had to do some pre-cal.
Really?
Yeah.
What was the pre-cal? SOHCAHTOA, unit circle?
It's angles like on the coordinate plane.
Yeah. Yeah.
All right, you all done with this one? Okay, almost started, and if I didn't give you enough time, at least you kind of saw where maybe you slowed down and you didn't know what else to do. Okay, so we are trying to, now notice there's no table here like the last question, but you still kind of want to think of it in the same way. I know when x is 1, y is 2, because they tell me that. The derivative comes from the table, so I don't even have to compute that. And then using this information, I can figure out where the new y is trying to go. Now, we're trying to go from 1 to 2.5 over 3 equal step sizes. So if we are trying to go end at 2.5, but we're starting at 1 and we're traveling 1.5, divided into 3 equal pieces, did you get that the step size was 1/2? So if we start at x equals 1, the next step would be at 1.5. The second step would be at 2. And the third step should be at 2.5, which it is. So we can kind of check to make sure that was correct. Okay, so the derivative, how do I know what the derivative is at the point 1, 2? All right, it's right here. When x is 1, the derivative is 0.3. So I know a point and I know what its rate is at that time, so I'm going to assume it stays at that rate for half of an x. So this would be, and I know you're having to type this in your calculator, but please, please, please put it on your work too. That's a big assumption to assume you know where this answer comes from, especially in March, April. So you're going to take your current y value, where you know it's currently at, and then you want to figure out how it's moving. So it's moving at this rate for this long. And when I did that, I got 2.15. So that should be the new y value. Did y'all get that? Okay. So again, this is why 5 steps is kind of tedious, because you just do the same thing until you get to the end. So now when x is 1.5, I can see the slope is 0.7. Again, it's up there in the table. So I could take its current y value, 2.15, that's where I know it is right now, and then add the rate. It's going this fast, it's moving this quickly for this long. Throw all that in the calculator and you get 2.5. So that means when x is 2, you can estimate that it's at about 2.5. Okay, next up, the slope when x is 2 is 1.2. So if he was at 2, and then he's growing at a rate of 1.2 for 0.5 x's, that gets you your next value, 3.1. That still sound good? I need y'all to double check my arithmetic. So when x is 2.5, now I'm estimating y is about 3.1. Do I need to keep going?
No.
You could if you wanted to know 2.75 or 3 or 3.75. If you needed further one, you just have to keep going. But here is our estimate. At when x is 2.5, y is approximately equal to 3.1. So it's probably not exactly at 3.1. That's not the point of this question type. The point is a reasonable, easy way to estimate how that's coming about. Okay, is there anything specific you'd like to ask about that question before I let you go? Yes.
Why do we have it on the place 1, 2 plus stack, and all the others we have the y value plus stack?
Oh, I'm sorry. This should have been 2.25. I wrote it down wrong. Okay, you're okay with the process? Everybody understands the formula and why it works? Okay. Then the next page, it looks like all of those ask for 2 steps. The last page has a couple at 3 steps. But you'll certainly want a calculator for some of those. Not trying to get you to do that by hand. So, I would like you to, I don't think there's any reason you shouldn't be able to finish up this assignment 17. So, go ahead and start on that. And let me know when you need help, please. I do have the solutions up from the people who made the worksheet, but if you'd rather come look at my work, I will leave it up here also, so whichever's easier for you. But again, you've seen the whole thing, so after a few practice questions, I'm hoping that this isn't a skill we need to practice a ton. What math score were y'all aiming for? On that ACT? Huh?
34.
34?
Just thinking as high as possible.
What is your current highest?
That was my first time.
Oh,
Hey.
Oh, really?
Yeah, okay. Okay.
So are you a junior?
Yeah, I'm junior.
Oh. Okay. Hey, no.
It's impressive you this
Well, that guy's a junior too, so. Yeah.
That's
Oh, I'm a junior. This guy too.
I'm a sophomore.
That's crazy.
You want me to take away your credit so you're actually a sophomore?
So what's the path that y'all took to even get here?
You just skip
Skip pre-cal.
Ah,
They go
okay.
hard.
So you doubled up freshman year and skipped pre-cal?
Algebra 1's under.
Oh, okay.
Oh, I have a new
So you should have done that.
a new help guide on your desk. It doesn't tell you what it is though.
That's nice.
Do you know what it is?
Units.
It's not in the whole unit circle, no.
What's the question? Oh, it's tangent, isn't
What
it?
is this that I added on your desk?
Oh, it is.
Tangent.
It is tangent.
Yes.
Tangent values of the unit circle.
Oh, then what's
That's
under it?
useful.
I just tried to change it.
Well, I guess we should know it. We should
That
know
is
it,
helpful.
so.
Well, I'm not gonna leave it up there all the time, but for the next few weeks, there you can glance at it and see the, remember the pattern.
Nice.
If you finish this in class, which I really think you should, you're welcome to turn it in as you finish, and I'll just go ahead and score it today. That way you don't have to turn it in next class. If you want to wait to turn in the next class, that's fine too. Of course, you could lose it though.
Bless you.
Bless you.
Thank you. You're welcome.
I have those little circles. You gotta accept that, but you want to have this record? Just make this make the other page. Yeah, this.
This is 90%.
We're not using this record right here.
This is not 10%. That's different.
This is number 16. This is number 17. Well, it's sort of a regular party card, single. You got that. Finish it all.
Okay, Anthony, I guess the question should have been, how many math questions do you think you missed out of the 60?
I had to guess on 3 of them, but then I confirmed that I guessed 2 of them right and 1 of them wrong. So we'll have to see about the rest because I'm very prone to goof and mess up.
So, at least one.
At least 1, yeah.
Well, if you only end up missing one, you might still get a 36.
Yeah, well, we'll see.
Impressive.
Hopefully. Let us know how you
Didn't get it.
I will. Yeah, I know.
I expected better.
I'm sorry, Calvin.
2.76.
I'm doing this.
What's the lowest math ACT score you've ever heard of?
I had a friend who had a 19.
I know someone who got like a 14.
Yeah, I have one. I need to.
14 is crazy.
I got a buddy who got 11.
Oh my god.
Name drop.
That would be horrible.
Your friend?
It's getting 11. That's like it's like 10%.
No, I had an Algebra 3 student once who had an 8.
8?
8.
Like a composite score.
8 on his math.
That's impressive.
It was just his
Very
math. I don't
impressive.
At least you'd have to be guessing the wrong answer. Right? That's impressive.
Like so.
Yeah, you just have to be, you guess on all of them and you're unlucky.
What's that? What is this?
No, this one says.
I don't understand.
Well, six.
So I have to find.
Yeah.
Probably.
Should be able to go back and
So I have to
figure
find what the starting value is. Is that all it is?
Should be the same.
Oh, yeah, it should be. Well, no, I'm not an idiot, I'm just tired because I didn't sleep.
I got home at midnight last night because I was out of state. Can't believe it.
I do sleep. I was listening last night, I go to sleep and then I was stressed. I had college class on the sport. This I do. Language.
It's just zero.
Not the nine.
So.
Oh, there is a number.
You're right, with the file.
Yep.
Since it's from 1 to 1, it's just 0, right? Thank you.
Same as Is it 0? You start at x1.
And since it's not above 1 to 1, it's just 0.
I think so.
Yes.
What do you say?
Plus.
I don't really understand. Let's try it.
Square root of 1 plus.
What are you talking about? What's zero?
Derivative of the picture is just square root 2. Isn't it just balancing equations at the bottom parts? Then it's you plug in and you find a 1 degree up to and all that basically. I'll watch you do this. Yeah, you find out how many moles of each is you have, and then you see the mole conversion to see how much is one mole of each.
Talking about physics or something?
Chemistry.
Chemistry. Studying chemistry?
I like
Chemistry, physics.
You see this shit?
No, I took that last year.
Oh, 2 squared is 4.
I do remember talking
Square root of 2 plus square root of 5 is just square root of 2 plus square root of 5, right?
One.
As a sophomore.
It's horrible. I mean, yeah, I get some of those. I got 2 on one of these.
No, it's just physics.
I got 5 on the other one.
That's good. Yeah. Are they different?
Yeah, it was like mechanics and one was like
That just sounds good.
college.
You remember Eli Hemminger, right? Yeah.
Yes, I know Eli
Didn't he get like a
Hemminger.
5 on all his APs?
Yes, he did.
Probably.
Every single one of them. Every gov got a 4, I think.
Oh,
He's so.
Eli, man, he's selling. I'm getting a 5 on every single AP.
Don't do that part either. Like, go like look at it.
No, he still like was failing, and then that ended up being his highest AP score last year.
I think he's only taken like 2 years. I got a 5.
Jack Kingston?
Enrolled not through UMAC, but through
Oh, I hate that guy.
Holy crap. You hate that guy?
Yes.
Why do you hate Eli?
No, Jack Kingston.
Jack and
Jack Kingston.
Jack Kingston, he's blonde, tall.
Oh,
immature,
Jack.
Yeah.
I used to play t-ball with him
He used to play soccer.
a decade ago.
Yeah, not a lot of people like him.
Why not?
He's very immature and annoying and loud, and he doesn't listen.
And he's
I don't
tall.
know.
He's blonde.
Yeah, that's not.
Blonde people, blonde people are just terrible.
Yeah,
You
honestly,
listen,
blonde people horrible.
You know, they're just naturally just not smart.
Oh yeah,
It's
horrible
it's
people.
very interesting.
I mean, like,
I don't know.
he just looks annoying too.
Yeah, actually, his nickname
Like-
nickname is Freshman Year was
Negative
Frog.
0.25,
People say he looks
since
like a
you're going
frog,
down.
so that's
Frog.
No, you shouldn't need to. The slope should pull you down if it is going down.
I don't want to meet this kid now.
Jack Kingston?
Yeah.
He's an interesting character. He used to be really, really annoying. And I had to sit next to him for AP Music Theory, and I think I just went to ignore him. An entire year I sat next to him.
That's weird. It's almost as bad as this guy for an entire year.
Oh yeah. I can't believe you're so unlucky, man.
I'm sorry.
Oh, 10 out of 10. Let's go. Finish
Another thing
that.
to keep in mind is this is the second new BC thing we have done since your first quiz. First being the ArcLink stuff you guys turned in, then I'm passing back to you. The second being this. So on Wednesday, we will look at a third BC topic. And we'll do, of course, another AB review of something or another. But shortly after that, we'll review and quiz again. I don't want to do 10 different BC topics and then make the quiz too much. So right now, you've seen about two of the three new things that should be on your next quiz: ArcLink and Euler's formula. Sounds like Euler.
Euler?
How do you say quesadilla?
Quesadilla.
Well, okay, well, if you say quesadilla. So I always call it quesadilla to my wife, but
That's
annoy her.
horrible.
But then one time I ordered one, and my brain could not say it because I was so stuck thinking it.
I'm not even joking, that happened to me one time too, and it was so embarrassing.
Oh yeah, it was terrible.
Because I used to say to my brother, like, jokingly.
Yeah, and then I said it to the stranger. Yeah. So I don't say it to her anymore jokingly. I learned my lesson.
Wait, X is 0 and 0. Wait, did I do the first one wrong? Oh wait, that was probably not. I did the back. This one? Yes, 70 minus 0.5. That's fine.
If you finish while in class today and you turn it in for me to go ahead and grade today, I've also got candy up here for you. So.
That's motivation. He said if you finish, you get candy. That's motivation.
Now, if you finish it, check your answers, and turn it in today, grab candy while you turn in your paper.
You're not cheating, are you?
No. Good. He's cheating himself out of an education.
Yeah, that's true. I do love making them correct.
Just thinking about it.
So.
I took this, and I did the derivative of this based on what we done earlier today. Was this?
Whack on. To get your Y values, all you do is plug in X equals 1 out of there, which you go to equals 0.
Yes.
And you plug in X equals 2.
To get my y prime values. Y values,
Y
yes,
values,
that's
not
right,
Y.
yeah.
Not Y values.
Yeah, y prime is easier because it's just that. And then for me, I just follow the same rules.
So 2 to the square root of 5 minus
On the last one.
square root of 11 minus so when you plug it in, when you're getting your value, f of, or h of 2, plug in x equals 2. So you get 1 plus 4, so it's a square root of 5 minus square root of 2.
I always use this one.
How did you find your?
So
Oh, you
first
plugged it in.
I just plugged it into
Yeah, you have to find the
the
rest of
ritual.
it.
Yeah.
Oh.
Just run it for the first one, the rest will come pop themselves out.
Oh, yeah, that's it.
Look at the expansion.
Do you recommend I get this one?
You should be able to feel like you can work these a little bit quicker each question, because once you know what the process is, it's just a matter of doing it. Thank you.
Thank you. Back page was there. I did the back page.
That's it, it's good. It's just got.
Okay, again, if something's giving you issues, you need to ask. I'm assuming you're going to get all your questions on this answered today, because you've got enough time.
How long could you get?
Still got about 25 minutes, so.
You the state marker. Am I supposed to find out this?
Also, this is I'm not sure if you noticed this, but this one is the expansion of Pascal's triangle.
Oh, is it?
Yeah, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. The 6 is because the 10 happens after the 5.
I did not notice that.
Are we supposed to start?
I have a stapler up there and a stapler over here. I assume you probably want to staple your papers from today. You don't have to ever staple for me, but if something is 2 pages, I would at least highly recommend you put your name on both. Also, the other problem is sometimes you'll only turn in 1 page if you don't staple it, but personally, I don't care if it's stapled. No candy? I thought that was your whole motivation.
No.
Yeah, I did not have this detail. I just wrote the whole So we can figure out
You approximately.
What did you get for this?
I also sent that. You said 6:30.
6:40, you said?
Oh, I'm saying, how are you on Stuco with 5 hours?
Wait, what's that?
Oh, it's like. This is Guy Thompson. I did not say that.
Why?
Wait, what did you say? Leon said that.
I didn't say anything. What do you mean?
Yeah, I'm gonna like.
He said he plays with
I did not say that. I said he. No, Thompson definitely said I. He didn't say he.
I was just saying.
How often do you do it, Thompson?
You have all of like the main.
Gosh, how are you on Stuco? I have a 6-year-old brother, so maybe like.
Oh,
That's even worse. That's even worse. Like, where's your mind? Oh my goodness, Brandon.
Like all these
What were you thinking
names
of?
themselves the exact.
What you were saying? Get your mind out of bed. Oh, that's my fault.
Okay, you can see my little notes.
These are
for sure.
For some reason, the concept you get that
Yeah.
Don't even think about it. Don't does now.
What?
It's just.
These two aren't right. Make sure you're checking your apples too. The rest that I looked at looked fine, but those two are not right.
I guess so.
Yeah.
I gave you full credit here,
Sandwich?
but I got a few things you can tell you. Like the sipping, like that. I started like, there's so many different
Everything's.
every single one I'm pretty sure. All the ones I've seen have so like
And you got a basket. You can get lunch this week.
Yeah, no, every
I think you can. You still have a student ID number like
had
yours.
like that.
Where
I can see what your mistakes were.
Except
It's okay with me.
I wish all they'd be able to do
That's
that.
fine.
Great.
Mind if I use that?
What did you get from
Sure.
Chicago?
Maybe once you're done.
No, I think they'll run the same system too, so much money.
every program.
Thompson, what you get from number 9?
Okay, if you're trying to finish with no homework, you got 20 minutes.
2 minutes?
20. 2-0.
2-0.
It is.
Because this is point 1. That's point 2.
Like,
Point 3. Point 4, and then that's point 5. Am I doing something? I think you need to do point 4. No, because the first one is.
This one's quite interesting.
X and Y.
Well, I can find the first quality.
Yeah, but you only did it 4 times. You need to do it 5 times.
The answer, yes, that is the
I know. But that's avoided.
You have to have text.
You know what I'm saying?
Which is quite different.
No, because still it's fine, just so you understand.
This one is 2 times 1.
When, like, the number of steps, I have to do it, but it's not, obviously you don't do it on the
So I imagine I did.
one you're looking for.
We're starting out at 0, so we're just doing 0.2.
Also, while I'm thinking of this whole assignment here, how much of this is actually calculus? Well, yeah, but specifically, what is calculus in any
You
of
need
it?
to know what derivative is.
You need to know derivative gives you slope.
No, you don't even need to know derivative. You just plug it in. Huh?
You need to know derivative means slope, but
Yeah,
that's
true.
about it.
That's true.
I fixed it, Mr. Townsend.
Okay, thank you. I already scored it, so.
Wait, why would you?
I go into the
I got one. I had one change.
I missed what you did.
Now, but you need to know that when I grade those, I don't usually check them for accuracy. So you need to make a habit out of checking them so that if something's off, you figure it out before you do it on the quiz. I just don't want you to think that when I give you 10 out of 10, it means that it's all right.
Oh, yeah, I know. I
Okay.
know you told that before. That's something that Sarah did as well.
Has Camden taken his quiz yet or no?
Yes, he finally did.
So,
Yeah, y'all can. Thanks for reminding me.
I'm still thinking this.
I don't know why that's not that problem. I'm trying to do all here.
They also
Just
really fast and really controllable.
Yeah, it's 0.4.
It's not even that many, it's not even that many decimal points. Every decimal point is approximation.
I got 2 again. Yep.
Okay, I am gonna pass back those first quizzes you guys took. Obviously, if you missed something on there, you don't need to look at it right this minute, but you should definitely look it over. I did try to help out just a touch by giving you a few AB questions that I thought you'd feel a little more comfortable with, and then only one of each type of our new topic. But I'm sure we will practice more of this again at some point.
Oh, I see what I got.
I really quickly glanced.
I wasn't being special.
But that's better.
For some reason, I thought 4 minus 1 was negative 5.
Okay.
I thought it was a negative 4.
Made up language?
Yeah.
You know, if you put all the time in it, it's
It's just this part right here.
I am. It's really hard.
And I thought that was negative 5.
It can't be hard.
It can't be.
Yeah.
Okay, but I
It's
still
really
got a high
simple.
score.
There's no nuance to it. It's
Is
just,
that a 14?
this is a concept.
You showed me your score.
You know how to do this? Like, if you change stuff to do that for sure. You're not a.
It was like the last
I'll do this.
It's really cool.
Oh,
There's
is
at
it
least 2
really?
ways to solve it. It's
Oh, I thought
difficult.
I used one.
The same that you showed me the other last time I was
that's-
trying to give you, it was like way easier.
Oh, okay, my bad. I just didn't know.
No, you usually put them in your
different challenges.
Ah, you know, you get to look back and go, oh my god, I'm so dumb.
Yeah, the right number of blocks.
I've done it at least twice before.
What should I do next grade?
It happens.
I'm so good, man. I'm actually good. Actually,
little bit, what is green?
Have y'all heard from Blake?
No, I think he's just.
I saw him last Wednesday past.
Have you heard from Blake or no? That's why I'm asking you.
I don't know. What's up?
Knowing Blake, which I don't, he's probably just.
Basis on when you relate this with 57 minutes. So this is like the first to the stage of excellent.
Supposed to be plus 29. Oh yeah, no, that's actually my cell.
Okay. Is that simple enough?
He's such a cool guy, like Eli. I aspire to be just like that when I grow up.
Backside. Aspire to be like
Just like Eli. I aspire to be just like that. He's so cool.
Need like a objective.
Smart.
Really?
Oh, yeah.
So sounds like you want to.
He's so cool. He always does everything right. He always has.
I'm actually
To describe the school, he does not have
Mr. Thompson, just so you know, I wasn't stuck on the last question. I forgot to do it.
Oh, okay.
I just saw something written there and I thought I read it. So I've been more careful.
Yeah, I'll go. This guy hates you, bro.
Yeah.
Yes. Does it look like I finished?
Here's the.
Alright.
Can I turn my table around? Or I can just turn my seat around. So we can play on Liam's steps.
Why would we do that? Oh, sorry.
Ooh, I love this game. What? See, what? What did you say? Stage 4 lung cancer. Oh, dude, when we were at the football game Saturday, some mom of one of the players came up. She had, like,
Ben, take a seat, please.
she was asking for a seat.
You can sit there, but I want you to sit down, please.
Can I go to the bathroom?
As long as it's not
The first or last 10 minutes.
past here, you're welcome to take it. You don't have to ask me. Wait, you need to put your name on the board.
Yeah, I definitely did.
No, you definitely
Like, sorry, haha.
And then you just take your name off when you get back. That way I know I get your password.
Oh, you failed? Try.
Not fail, it's good.
No, good is getting all of them. Which one's the one that you
Get all
start
of
with?
it. That's really good.
I have.
Hey, Brain, I bet you $1 that you don't get all of them first round.
Yeah, I probably
I bet
did
you
all of
did.
it. Second million? Yeah. I'd rather not lose a million.
But there's no more cards.
Don't you leave the top one open?
Matter of fact, I bet my life that there's no eggs left on the board.
Wait, I've been able to close all of them.
I would play Song. It's to roll the die, you draw a card and move.
I have the last one.
Yeah, my last card was
Can you just put it here?
Yes, please.
You gotta see what I did. It's actually what
You're not thinking. Use that big brain.
So I back to this. Squares and then on the back. I forgot to do that.
There's no way this
Nope.
guy can take golf keys and football Brain loves to do that.
Turned mine in and then forgot to grab out some candy. That's the whole point.
I go here. Either way, I'm gonna end up getting.
Doesn't have any of the.
I go. That one's just.
I like green. I'm a good
Really? I've never enjoyed a grape candy. I think they're bad.
I got the same.
I'm sure I am. I don't know. I wish I liked them.
You can't get all of them. You can't. There's always gonna be one left.
Here's my front
You
page.
should have heard what I said to Jackie.
Wait,
The tenors have to hang on. The tenors, because you know, you just never
Here you
stop
go.
playing. So, hey, you know, Jack, maybe you guys will watch the majors. It's like, here, I'm gonna act like you. I was acting like Jack, you know, with that one voice. Yeah, it was great. He didn't like the very much. He really should have done it.
Okay, you guys are down to about 7 minutes here. So if you are not finished, you need to finish it up for homework. I will ask for it at the start of next class.
You should try to do this.
How old is he?
17.
You suck so bad.
17 and really good stuff.
All right, and here's today's puzzle.
Oh gosh, I didn't know that she only so.
Say the color of the word. Say the color of the word. Red, yellow, blue, yellow,
red, green, red, blue, yellow, green,
Oh,
yellow, green, red.
Just take on my.
He said y'all are wrong.
Yes, let's go.
It's easy.
Yellow, red, green, black.
Okay, who thinks they're good at it? That wants to actually. Okay, Thompson.
White, black.
All right, everybody give Thompson a chance to try.
Should I go faster?
The quicker the better. Yeah.
Red, yellow, blue, green, yellow, red, green, blue, yellow, yellow, green, red, blue.
No,
yellow,
you already messed
Yellow,
up.
yellow, I heard a yellow, yellow over
What?
there. I heard a yellow, yellow.
There's two yellows.
Where they at? It's
Because
a
when we say the
color,
color, I can't see the word.
Wait, you say the color of
Say
the
color
word.
of word.
Oh, all right.
Like glasses, so they can't see the words.
Oliver's next. Go for it.
Red, yellow, blue, green, yellow, red, green, blue, yellow, blue, red, green, red, blue, yellow, green, red, red, blue, yellow, green, blue, yellow, red, white, black.
I think he did it.
I can't even see the words.
Oh, that's cheating then. He cheated because he didn't have his glasses on, so he couldn't read it.
You gotta squint. You gotta squint.
Alright, I remember there was a trick to this. You start by clearing the bottom.
I misread the instructions.
Yeah, we should probably.
Yeah, alright.
Just blur your eyes. Just blur your eyes.
Hey,
What? Just blur your eyes and it's pretty easy.
Uh-huh. Unlike you though, I don't cheat. Wow, Ben. No, I'm just smart. Alright, I'm gonna try that again. Okay, you're gonna grab one. And you're gonna go back down. And then go back down.
Oh, that's close.
Please, I've never gotten sad.
Oh, darn.
Hey,
You do it.
Wouldn't this be right? Since if you're going backwards, you need to be able to go forwards again. And if you started with this value and going to 1.5, then this would be correct. Because going backwards, you wouldn't do it by that, you'd do it by that. So,
Actually, yes, I think you're right. I think I was looking over here.
yeah, so it'd be 0.3 times 0.25 plus that.
Nope, that should be 3.75.
No, like, if you were to do it in reverse, you do 3.825 plus 0.3 times 0.25, then 3.9 plus 0.4 times 0.25, which is correct. Because you can do it in reverse, and it should work. To do it backwards, it would be, you wouldn't do 0.6 times 0.25, you do 0.4 times 0.25.
Yeah, but my step was negative, so I'm balancing it out with that.
It still is not 0.6 times 0.25, it would be 0.4 times 0.25. Since this is going there, this would be going backwards.
I did better than that.
Because this is the previous value.
I don't think so.
I mean, if you instead did it in reverse, like you tried it with this, it should be the same forwards and backwards. And this way it is, because if you start with this in 1.5, given this value, it would give you 3.9 and 4.
Okay, but see, I mean, I'm basically doing it backwards too. 1.5 we're at 4.
Yeah, but if you tried it, if you started at 3.75, you wouldn't get 3.85 going in the other direction.
Are you using the slope here?
Yeah, if you started with this value and did it this way, you wouldn't get 4.
Okay, well
with that.
This is the answer I got, and it's the answer that the person who made the worksheet got. So you're the only one that's different there.
Hands on win tells you lose.
I think maybe you need to write it out more, and then you must, your reasoning sounds correct. I don't disagree with any of your reasoning, but there must be some arithmetic thing that's still off a little bit.
I mean, 3.825 plus 0.3 times 0.25 gives you 3.9. But if you did that with that value, it wouldn't give you the next value.
Why would it be 0.25?
Because that's the step between each of these, 1 to 1.25 to 1.5. Negative 0.25 would be backwards. So if you tried 0.375 plus 0.25 times 0.3, it wouldn't be 3.85.
Heads or tails?
1.75 plus.
1.416, I'm almost done.
That's 2 times. That's 2 times. That's literally scales.
Let me do it.
0.25 per step.
Heads or tails? Heads or tails?
You see? But if you did it with 0.825 to and then did it to 3.9 to 4, that would work.
I know what you said that was incorrect. Have a good day. It doesn't necessarily have to be the same frontwards and backwards, because if you're going this way, you're using the slope at the left exponential values, but if you're starting here and going this way, you're using the right slopes. It's not necessarily the same left and right. Try to go it the other way and see that you get different values. Try it here.
3.825 plus
No, I'm
0.
sorry. Start with the one that you know. Start here, and then go backwards like I did, and you'll see that you get different values. I don't know how to convince you other than get you.